Okay, section 4.5. Complex circuits will be the fourth and final type of method for connecting a circuit that we're looking at in chapter 4. A complex circuit configuration is one that contains components that are neither in parallel nor series with each other. If the circuit can be reduced to a single resistor, it is a series or parallel. If not, it is a complex circuit. And so let's look at some examples on the following slide. Here we have 4 circuit types, and we want to take a little time to look at these and see, is it feasible to reduce these to a single power supply and a single resistor, which would make them either series or parallel. If we cannot do that, then they will be in a category we call a complex circuit. Okay, here we have the first one. Let's see, here we have a power supply, and we have here we have R1, and then we have to these components over here. Well, obviously R2 and R3, we could eliminate those, and that could be replaced by a single component, and then this replacement component in R4, those could be in parallel, so that would make a single component for here. So we have reduced that to R1, this component here, plus R5 at the bottom, and this is a series circuit, so we could reduce this to the power supply, and the one circuit would be, which would be the added values of these 3 components. Now the next one, simplify. So here we have another circuit. Now in this one we see we have R1 and R7, those are obviously in series, but over here we're going to run into some problems, and our problem area will be here with R6 and R5, and we won't be able to resolve this to a single component. I suppose if R5 were not in the circuit, or if R6 were shorted, we could reduce this, but in the case the way this is drawn, this will be complex and we will not be able to reduce it. Okay, here we have another circuit. Let's see, this one we could go in, and these 3 components are in series, so we could remove these. We could simplify that. Here we have a parallel. We could reduce that to one component, and then this component and this component would be in series, so we could reduce those 2, and we would have this component. And let's see, let's redraw this over here. And so we have this resistor coming up like this, and then we have this component here, and then this component. Now this component is connected to the power supply and this resistor, so we could just as well show it like this. It'd make it a little easier to see that it is in fact in parallel, and these 2 are in parallel, so we could replace that with a single component. And so now we have the power supply in series with these 2. We could add those together, and then we have reduced this to a power supply and one component. This particular circuit, this is actually the Wheatstone bridge that we had looked at in the previous section. It wasn't drawn like this, but this is a Wheatstone bridge. And the R3 is the component that will make this a complex circuit. If R3, if we opened this particular component, and we just had R1 and R4 in series and R2 and R5 in series, and we could look at this is in parallel with this, we could reduce this, but because R3 is here, we're not going to be able to simplify that. So in this section we looked at the complex circuits, and we looked at simplifying them. Here we have the 4 that we started with. We found out that this one we could, this is a series parallel, it could be reduced to a single supply and one resistor. This one we could also reduce. This one was complex, we had problems with either of these two components. If we either short or eliminate, we could have, but in the way it's drawn, it is complex. And also with D here, this is also a complex circuit because of the presence of R3. So this introduces complex circuits. We won't be doing a lot with complex circuits except recognizing that they are complex circuits.